Okay, so now that we know some basic facts about a parabola, right, the backbone of it being a quadratic function, ax squared plus bx plus c, let's try to figure out how we're going to take advantage of some of those nice features about vertices. And it turns out that what we're going to be working with mathematically are called transformations. So what a transformation is, if I can get it spelled right, what a transformation is it's basically it takes a basic shape and it shifts it left, right, up, down, stretches it, right, makes it longer, compresses it, makes it shorter, right, or even flips it on its head. So those are our basic transformations. And it turns out that all parabolas basically have their origin, if you would, their beginning starts with a relatively simple graph of y equals x squared. So it's kind of like here's the ancestor, if you would, of all quadratics. Everybody has their beginning right here. And what we do is we transform this graph. So let's take a look at what this graph looks like. Again, right now, let's point plot. And let's throw in some -1, 0, 1, and 2 just to get a figure of it. If I put a -2 in here and I square it, I get 4. If I put a -1 in here and square it, I get 1. If I put a 0 in there and square it, I get 0. 1 squared is 1, and 2 squared is 4. So there's basically the data points for y equals x squared. So when I go to a grid, right, so right behind us here, so when I go point plot all that, right, I got -2, 1, 2, 3, 4. I've got -1, 1, 0, 0, 1, 1, and then 2, 4. So there's basically our parabolic graph. And you can see all the aspects we talked about, right? The vertex is actually sitting here at 0, 0. That's the low point in this case, right? We have a nice point of 1, 1 and -1, 1. We have that nice symmetry going on, right? So -2 creates a 4 and +2 creates a 4. So very nice and symmetric. Okay? So all the qualities are there. And last but not least, our axis symmetry is basically the y-axis. So how do we transform that basic shape? Well, again, we're either going to take this shape and move it up and down. We're going to move it right or left. We're going to flip it around, right, so it's pointing downwards. Those are all the transformations we're going to do so that I can create any other parabola that we know out there. So how do we do that? The first transformation we're going to consider, right, are basically transformations that impact the input. And of course, we know that input is going to be x. So this is what it's going to look like. I'm going to say, let's graph y equals x minus 2 squared. So notice I'm taking all my inputs and I'm subtracting 2 from the input. So it's almost like taking this grid here and subtracting 2 from them all. All right, and so because I know what's going on, I'm not going to subtract 2 from these guys. I'm actually going to start at 0, put in a 1, put in a 2, put in a 3, and put in a 4. So if I put in a 0, we get 0 minus 2 squared, right, which is a -2 squared, which gives us 4. If I put in a 1, 1 minus 2 squared, well, that would give us a -1 squared, which gives us 1. If I put in a 2, that gives us 0 squared, which you know to be 0. If I put in a 3, that gives us 1 squared, which is 1. And if I put in a 4, I get 2 squared, which is 4. So there would be the data points for this new function that's basically taking the input of x squared, right, x, and subtracting 2 from it. So let's go to a grid and see what happened. So when I go to the grid and plot these points, right, so now I'm down here, right, we have 0, 4 is on the graph, 1, 2, 3, 4, 0, 4 is on the graph. We've got 1, 1 on the graph. We've got 2, 0 on the graph. 3, 1 is on the graph. And then 4, 4 is on the graph. So there's our parabola. And in relation to the one that we had, let me try to make that really nice. Notice what happened is my intercept, my vertex, is now sitting at 2, 0. So it used to be at 0, 0. It's now at 2, 0. As a matter of fact, that point, which is 1, 1, is now at 3, 1. And that point that was at -1, 1 is now at 1, 1. So it's like I took all these data points and I shifted them over 2 units. And that's basically what happened here. So what we end up with is we end up with a shift right 2 units. So that's what essentially happened there. And you can take that to the bank. If we were going to do x minus 3 squared, then we're going to have a shift right 3 units. All right, so we can get a really quick sketch. I would just go over 1, 2, 3, and basically take all those data points. And so there would be a really rough sketch, all right, of x minus 3 squared. It would have its vertex sitting there at 3, 0. Its axis of symmetry x equals to 3. So if we subtract something from the input, we're shifting things to the right. So it makes a really fast way to make a sketch and track that vertex. What happens if we add? Well, let's say if we add x plus 2 squared. So again, we're adding 2 to the input. And so again, I kind of know what's happening here. So I'm going to choose wisely my input so we can see what's going to go on visually. So if I put a negative 4 in here, right, we have negative 2 squared, which is 4. If I put a negative 3 in here, we get negative 1 squared, which is 1. If I put in a negative 2, we get 0 squared, which is 0. Negative 1 plus 2 would give us 1 squared, which is 1. And 0 plus 2 squared would give us 2 squared, which is 4. So I now have those data points to plot. So if I go to my grid now and plot those points, we have negative 4, positive 4. We have negative 3, 1. We have negative 2, 0. We have negative 1, 1. And we have 0, positive 4. So there's where my parabola is at now. Now remember, the original one started right here. So basically you can see the graph shifted over 2 units to the left. And so that's what basically this does. So we have a shift left 2 units. If we wanted to shift left 3 units or 4 units, right, we would consider the graph of x plus 3 squared. That, again, a really quick sketch, I'd be moving that vertex over at negative 3, 0, and it would be basically doing something of that. So the original function would be over here, but it, at 0, 0, but it's been shifted over. So there's basically a way that we can track the vertex left and right. We basically subtract something from the input, that shifts us to the right. If we add something to the input, that shifts us to the left. How far do we shift left or right? Well, whatever number is being added or subtracted. Okay, so there's our first stint into transformations. The rest of the transformations actually do output. All right, and we'll talk about those. But right now, since we're manipulating input, to kind of summarize here, there's our basic graph. If we subtract something, we move it to the right. If we add something to the input, we end up taking that shape and moving it to the left. So it's literally taking that shape and shifting it left and right. To the right, we subtract. To the left, we add. See you guys in the next video.